Hi, this is Kumar Singh from Designed Analytics LLC and welcome to another episode of Thursday Throwbacks. Well, as you know, the purpose of this video series is that we kind of revisit some of the important key research paper and milestones in the world of technology, artificial intelligence, to be more specific within technology, but I expect to cover milestones beyond AI as well. But today's milestone is all about AI because we are going to review a research paper that introduced the concept of neural networks to the world. The same neural networks that are kind of the foundational, I will say, not exactly the foundational logic, but the building block, one of the key building blocks of the large language models that we are also familiar with today, right? So let's get into the paper. This paper, logical calculus of the ideas eminent in nervous activity, was published in the Bulletin of Mathematical Biophysics. So in 1943, McCulloch, a neuroscientist, and Walter Pitts, a logician, came together to publish this paper. I wasn't sure what a logician is, so I had to search basically, but totally non-relevant, right? So in this paper, McCulloch and Pitts, and just in case I'm butchering the name, McCulloch, we are going to refer to McCulloch and Pitts as MP, right? If there is any fleeting chance that I'm butchering the name, MP is a safer option, right? So in this paper, MP tried to understand how the brain could produce highly complex patterns by using many basic cells that are connected together, as we know now, right? Now, these basic brain cells are called neurons, and MP gave a highly simplified model of a neuron in this research paper. Well, this model of a neuron, which let's call it MCP neuron for short, has been very important in computer science. In fact, if you are an electronics nerd, if you like assembling circuits, playing with electronic and electrical circuits, right? So you can buy an MCP neuron at most electronic stores, but I think they are called threshold logic units or something like that, right? Okay, so coming back to the paper, a group of MCP neurons that are connected together is called an artificial neural network, and that's where the term was introduced, right? So in a sense, as per the paper, the brain is a very large neural network, which is a fact, right? Even though we do not exactly replicate the functioning of that biological neural network in the artificial neural network, but it has billions of neurons, right? And each neuron is connected to thousands of other neurons, right? So MP basically showed how to encode any logical proposition by an appropriate network of MCP neurons. What this means is that in theory, anything that can be done with a computer can also be done with a network of MCP neurons. Right? They also showed in this paper that every network of MCP neurons encodes some logical proposition. So if the brain were a neural network, then it would encode some complicated computer program. But as we know, the MCP neuron is not a real neuron, right? It's only a highly simplified model, right? So hence we must be careful. We must be careful in drawing conclusion about real neurons based on properties of MCP neurons, and in my opinion, vice versa. So the study of their neuron is enlightening actually for several reasons, right? So if you study, you will see the early history of the development of what would become the impressive artificial neural net programs that we use today. Second, you will see the evolution of a computer model that gradually moves away from the classical concept or conception of a digital computer to the emergence of what we call a non-classical computer. These non-classical computers are making a significant contribution in the research that is being done, right, to better understand the working of human brain, right, and plethora of other areas. And finally, you will come to appreciate the vitally important contribution that mathematics has made to the scientific study of the mind. And this paper is a stellar example of mathematics in practice. So, why was it a milestone? To summarize, it bridged neurosciences and mathematics. For the first time, brain function was described using formal logic and computation. Though primitive, the neurons shared in the paper, right, they share core ideas with today's artificial neural networks, right? It inspired generations of research, including work by Newman, Marvin Minsky, and later the development of perceptrons and backpropagation of the neural network. Well, so yeah, this paper was the first to show how networks of simplified neurons could perform logical reasoning, and this foundational insight created a blueprint for computational models of the brain and marked the birth of neural networks in AI. Thanks for watching. I'll see you next week.